interface counters. And, well, if you want to have the full picture for every single field, well, take the traffic capture. Now, who knows about Netflow? OK. So I've been trying to explain the use cases for flow monitoring. And the best way I found was to look directly into the fields, right? We're supposed to be geeks anyway here, right? So if you look at this Netflow version 5 flow format, try to see this as an Excel spreadsheet. If you would have all the packets entering an interface or entering a router, and you could classify all of them according to this. So what do we have? The usage, bytes and packets. Then the time the flow started and the time the flow ended. The incoming and outgoing interface. Type of service, TCP flags, protocol. Then at the top right-hand side, the IP addresses. Who's communicating with who? And with the UDP and TCP ports, you know what they do, at least layer 4. Right? And then some routing information like, what is my IGP next hop? Where the traffic goes in terms of BGP. It leaves and goes to the destination AS, blah. And the prefix mask. So again, try to imagine this like an Excel spreadsheet. If you would have all your traffic with this Excel spreadsheet, you could answer the who with the IP address. Somehow the what with the TCP UDP ports. The when with the flow start. The where because you've got the interfaces and you know which router is exporting this. Right? So it gives you a lot of information. So the type of use cases you could be solving is potentially security monitoring, right, with the TCP flags in there. Capacity planning, right? I've got my core with all my routers in there, and I want to know the BGP next hop, that's a different field, is there available as well. Or you have the BGP autonomous system. Okay? What else? Simply traffic monitoring or billing, right? So all these use cases are available depending on which fields you take there. Yeah. Now, again, that's one slide I show to my customers, but I want to make sure you understand this. In a typical router, you've got all the flow records in a cache. So I've got my cache. One packet arrives. The first time I've got no entry in there, I'm going to create one flow entry in my cache, right? Then a second packet comes, two solutions. Well, it's a different flow, then I have a different entry. Or it's the same flow, and I just update the number of bytes and packets. Now, to know if it's the same flow or not, we've got the notion of a key field. A key field, this is what is orange there. IP addresses, ports, protocol, type of service, and interface, ingress interface. So these are the values that make a flow record unique. If any of these, if any value of one of these 7 key fields is different, this is a different flow. Okay? So from the cache, we've got some timeout. And after some timeout, we're going to expire the cache from the flow. Expire the flow from the cache, sorry. And then we could do some more router-based aggregation, or we could directly export it. Okay? And by the way, every single time I use a term in there, you're going to see that we reuse the same term in Ipfix, like timeout, like cache, like collector. In Netflow, we export with UDP. We're going to see that we have the choice of, that Sctp is compulsory in Ipfix. Okay? Next slide. So the history. Well, we're going to celebrate the 20th anniversary of Netflow pretty soon. Now in the ITF, I'm not sure who came up with that acronym, RTFM, but I like it very much. Yeah. But in this case, it means real-time traffic flow measurement. It was done from 97 to 99, small mistake there. It was the first set of RFCs that were dealing with flow monitoring. So, okay, one more thing I wanted to mention there, and again, I just want to put a couple of key messages in there for the Ipfix. But what we learned based on Netflow version 5 is that most customers, they wanted something different all the time, right? They wanted, for example, to support IPv6 or BGP Next Hop, etc. So we realized that using what I call the Excel spreadsheet with a fixed format was not working. So we need something that was extensible. That's why we had there the Netflow version 9 that works also in a template-based mechanism. But also what we need to do after that is change the metering process to make sure that all the fields were available and that you could choose exactly which one you want. And my key message on this slide is that Netflow is a very confusing term. It means at the same time the metering process and the exporting process, right? But we made it clear in Ipfix that we've got this term, metering process, and that one, exporting process. And Ipfix is about this synchronization, synchronizing the exporting process. All right, then again, coming back to the use cases, we saw the use cases on Netflow version 5. Now, I want to show that there are way more information elements. And typically, we've got things from the layer 2 header, IPv4, IPv6, right? Almost every single field is in there. And you can choose independently how you're going to construct your flow records. And one of the advantages of doing this is that you might have flow records for a specific use case, like security, and you send it to a security collector. All right. Next slide. And there are some more from routing, from transport, even to a single TCP flag if you want to. All right. So again, those slides are not there for marketing reason. You should try to see if it's going to solve the use case you have in mind, right, by selecting the right information elements. And now, whenever we'll speak about Ipfix, there is a registry of Ipfix information elements. And in there, we have right now 400 information elements, or almost. Okay? Now, the two previous slides were typical key fields. Remember, a key field changes the definition of the flow record. These are typical non-key fields, right? Counters, number of bytes, packet. And like in SNMP with counter 64, we've got packet longs and byte longs. And then we've got the timestamps. Total length min, total length max of a packet. TTL min, TTL max, right? So again, some more use cases you could be solving. Okay. Just before going there, as always in my session, if you don't ask questions, then I'm asking questions, right? Just to make sure you're awake. So you know the difference between a key field and non-key field, right? And one example I take on a regular basis is, should the outgoing interface be a key field or not? Should the outgoing interface be a key field or not? Yes? No? Okay, so there are no good answers because the answer is it depends, right? I'm going to show you two use cases. So I'm the router, I've got two interfaces, and let's pretend I do load balancing, right? Per packet. Okay, stupid, but per packet. So my first packet goes there, right? Interface number 1. I'll create my flow record. The second packet goes there. If it's a key field, well, that's a different flow record. I've got a second entry there. Every single entry has got one packet, right? Now, same thing, but it's not a key field. The first packet goes there, one packet in my flow record. The second goes there, but it's not a key field, so somehow the definition is without the interface. So this is the same flow records now that was going there with 2 packets. Okay? So basically, it depends which problem you're trying to solve. If you want to see if you have load balancing per packet, key field. Otherwise, maybe not. Okay? History. The buff was in IETF 51. And by the way, this is the full history of all the documents. I just want to highlight a few things there, right? What's in red. So we had like several candidates there. Because the idea of Ipfix was to say we want to use like common practice and standardize this. But it turned out that we had like 5 candidates. And starting there, we said the only way to choose is to have a set of requirements. What do we want this Ipfix to do? And based on that, Netflow version 9 was the base candidate on which Ipfix was standardized. Then when we decided that, we spent about 2 years strongly debating what the transport should be. Well, we've seen that Netflow was UDP, right? We've got a lot of flow records that need to get out of the router directly. These days, we've got a platform with 13 million flow records in hardware, right? So that's a lot. But somehow UDP was just not good enough for the IETF, because if the protocol would run on the internet, it has to be congestion aware, which is the first statement. Okay, so Sctp was selected as the protocol to implement, while UDP and TCP are may protocol. All right, so there we've got the 2 most important RFCs for Ipfix. The protocol, RFC 5101, and the information model 5102. Yes? Now, this one is also an interesting RFC to read. This is the architecture. And basically, what I tried to explain in a couple of slides, right, was the flow records, the timeout, the expiration, and we export this. And then there were a couple of RFCs that were like extensions or guideline or applicability or testing. Later, we focused then on the mediation. We had some operators telling us, well, you know, I've got plenty of devices from different vendors or different software trains, and they're not always compatible, right? Some of them export Netflow, some export Sflow, some export something else. So we need to regroup all this to a collector. But this collector would be specific, would have some extra functions like mediation. Like I want to aggregate flow records. I want to filter and send one part there, one part there. I want to anonymize data. So this was the work behind this mediation. And we started with the mediation problem statement, then followed the architecture, the different functions, and the protocol. And also one thing there is, this is a config, Ipfix config RFC. That's the first one that contains a YANG module which is not defined in the NetMod working group. NetMod is the working group for YANG modules. All right? So the current status. So Ipfix is a mechanism to export repetitive information. Okay? This was initially focusing on flow information. And you've seen that from a couple of information elements that we're able to export. However, as we're going to see along the session, this became like a generic push mechanism. And you can export basically what you want. And now Ipfix is applicable whenever you export those same structure all the time. Right? Questions so far? So it's all clear, right? Now the architecture. And what you'll see in there is that the introduction was planting some terms that are used in Ipfix, right? And that makes sense because Ipfix was based on Netflow. And something funny, I mean, in Ipfix, the version number in the header is 10, right? It's 9 plus 1. Okay, so we spoke about metering process, exporting process, and try to just memorize the acronym. MP, metering process, EP, exporting process, and CP, collecting process. So we know it, the metering process will look at all the packets, will classify those packets as flow records, will maintain those flow records in the cache, and finally will expire the flow record. And by expiring, they send the flow record to the exporting process. And from there, the flow records are sent to the collector. And this is the specific process there on the collector, the collecting process. It receives flow records, all right? So that's a nice figure of what I just explained. And we have on the left-hand side what we call the observation point, which could be interface, a line card, a router, a probe, you name it, right? And, sorry? Okay. So metering process and exporting process. Those two are based on what I call a router or a switch, but the right term is an exporter or a device, right? Then we've got the protocol there, and it goes to the collector. Make sense? Good. Now, there is no limitation, actually, because, as I said, we might have a lot of flow records there, right? Now, we could be sending this to one collector or actually to multiple collectors. And what we could do is duplicate information. Why duplicate? If it's UDP, you might be losing some UDP export packet that contains flow records, right? What you could do as well is have a backup. If you use Sctp, you could say, this is my primary link there. But what I want to do is that whenever my Sctp association is down, I will just switch over to the collector number 2. Or what you could do is say, well, this guy is actually a security-related collector, while the other one is for capacity planning. So I will select different flow records there, even with different flow record templates. Okay? Yes. All right, so the mediator, that's what I said. The mediator is a function in the middle there, where typically we receive flow records and then from multiple devices. And this mediator contains a function that we have standardized. And this function could be, I want to aggregate from many sources, from many exporters, aggregate information and send it to a top-level collector. I could be doing also like anonymization, right? Here in Germany, we can't export the IP address of the end user. So we have one draft that says this function there, and by the way, this is called like the intermediate process. This intermediate process could be anonymization. It could be flow selection, right? Typically, I've got this guy, and this is the sysadmin of a university. He's got multiple devices there, but he needs to send the typical record to the real university if the sysadmin there support multiple groups. Okay? And now that's it for protocol structures, unless you've got one question. Then, thank you.
So basically, we've talked about how all of the big bits of Ipfix fit together, and now I'm going to talk about how all of the little bits of Ipfix fit together. So we're looking at the structures in the protocol themselves and how this is represented on the wire. So a quick terminology overview. So the message or the stream of flow records is transported in a stream of Ipfix messages. A message contains a message header and one or more sets. A set contains a set header and may be one of these three types of sets. It can be a template or options template set. These describe the structure of data sets, and that's a little bit to absorb right on the front, so we're going to go through the next 5 or 6 slides with a bunch of pretty pictures of this. So yeah, here's a message. The message has a message header. The message header has the version number, which is 10. So it's basically sort of a magic number for Ipfix. It has the length of the message in octets. That is a 16-bit number, so Ipfix messages are limited to 64K per message. Then the export time in epoch seconds, a sequence number which can be used for drop message detection on UDP, and then an observation domain ID. So an observation domain is kind of a way to group flow records that come from sort of the same set of observation points and metering processes. The technical definition in the protocol is that a given packet will be observed in a single flow per observation domain. So if you split things across observation domains, then you know you may be seeing a flow record for the packet and then another flow record containing the same packet as it's measured farther down the chain. Beyond that, we kind of leave the use of the observation domain up to the implementer. I think for Cisco, Benoit, correct me if I'm wrong, that's the line card number for Cisco. And then the message, basically you see the message header, you know how long the message is, and then you have a number of sets which fill in the message. A set header is basically, it's a much smaller header, it's just 4 bytes. It has a set ID, which defines the type of the set. We'll get into that on the next slide. And then the length of the set. So essentially you have like sort of 2 levels of structures, all of which are length encoded. So you have the message length, and you can sort of split messages up based on that. And then the message itself is split into sets, and you can tell the boundaries of the sets based on the set length. So next slide. So what do we put in these sets? And how do we know what the structure of the records in the sets are? So Ipfix is template driven, and this is done via templates. So a template is a description of the structure of data records within a set. So this is, every template has an ID. The template ID then refers to the set ID containing the data records that the template describes. And we have a picture of that later. A template itself is essentially just an ordered list of information element and length pairs. So it's like, we see, here's an information element, it's this many bytes long, here's an information element, it's this many bytes long, and then each data record has values for each of these information elements in the same order in which they appear in the template. And these IDs are essentially field type information for templates. So here's what a template looks like. A template shows up in a template set or an options template set. We'll get into what options templates are in a moment. It has each template within the set then has a template ID and then a count of information elements. And then you just have pairs of information element ID and length. So a message can contain any mixture of sets. We can say that this message here has 3 sets in it. It has a template set followed by some data sets. And we have, the template set has, the set header. The set header says that the type is 2. So 2 is a special number, which means this is a template set. And then we have template IDs, and then data sets with set headers that refer back to the templates for those IDs. So next slide. And basically, yeah, so you know when you have a template that then the set header refers to the template ID. Next slide. Now, it would be really kind of inefficient if for every single message we had to have all of the templates for all of the data sets in that message. Data sets can refer to templates that have been exported in previous messages within a stream. So often you'll have a few messages right at the beginning that define the templates that you're using, and then a whole bunch of messages which are just sort of data, the structure of which is referred to in these previous messages. So this is where a lot of the efficiency, the export efficiency for Ipfix comes from. So what are these templates made of? They're made of information elements. What can you do with the information elements? And it turns out anything you really need to do with flows, and most things you need to do with network measurement, we already have information elements for those. We've got the traditional 5 tuple, sort of all of the fields that Benoit showed in the previous slides for Netflow. So these packet treatment things, what happens at a router. timestamps of varying resolution from seconds all the way down to nanoseconds, various sub-IP header fields like WLAN SSIDs and VLAN tags and MAC addresses, all of the counters. So we have the basic counters like delta counts of packets and octets. We have sums of squares so that you can do standard deviation measurements. And then a bunch of flow metadata information. So, where did we see this flow, the ingress and egress interface, the direction, selector IDs, things like this. We've got about 400 of these. They're in a registry at IANA.org, assignments Ipfix. This registry contains then the number, the name, and a whole bunch of description information. So basically, if you see an information element and a name, you can go to the registry, you can read the description, and you can know exactly what's going on inside that information element. So one of the other big things, we don't have just 400. The reason that this is an IANA registry is that it grows. This is the primary way to sort of extend Ipfix by defining new information elements. So the IANA registry is extensible per expert review. So basically you go to IANA and say, hey, I'd like a new information element. And then there's a review process where sort of experts look at that and say, yes, well, yes or no, or hey, maybe you should try and do this. This is formalized and described in draft IETF Ipfix IE doctors, which is in the RFC editor queue. So we didn't get a RFC number for that in time. So, but search on that and you'll be able to find it. There's another way to extend the information model for experimental, commercially sensitive, or otherwise private information elements. Let's say you have an exporting process and you have a particular algorithm, you need to export things, but you don't really want to tell anyone other than yourself what the definition of that information element is, because it's sort of, that's your secret sauce, right? So you have an exporting process and a collecting process, and you tag them with these enterprise-specific information elements. We're going to see a little bit later exactly how these work. So we said that information elements are essentially, a template is a set of information element number and length pairs. It's a little bit more complicated than that. So all of the types have a native length associated with them. So an IP address, you really need 16 octets if you're exporting an IPv6 address, or 4 octets for an IPv4 address. But there's also, for export efficiency, you can use something called reduced length encoding. So all of our counters are 64 bits, like so. Your flow length in packets and octets. But anyone who's done a lot of sort of like large flow measurement on the internet, almost all of your flows are 40 bytes long and 1 packet long. And you don't really need to export all of the zeros there. So you can actually, for a template, you can use what's called reduced length encoding. You can say, here's this 8-bit or 8-byte information element, but I'm going to export it to you using only 2 bytes or 4 bytes. Not all of the things that we'd like to reference are fixed length. So for example, maybe we want to not just have the interface number that a packet came into or out of. We might want to have the name of the interface, or if we're doing wireless monitoring, we need to put the SSID of the WLAN that was on that, and that's a string as well. So there are 2 different encoding methods for variable length encoding. It's a length prefix thing. It basically says, here is the information element has a special value that says this is variable length, and then when you read the data record, you see the length of that particular instance of the information element within the data record. So let's, can everyone kind of see this, or is this a little bit too much of an eye chart? Can you read what's going on here? Okay, good. So this is an example template for like the simplest flow that I could think of. Here we're making the point that here we have the traditional 5 tuple, and that is the flow key. And then we have the flow start milliseconds, flow in milliseconds. So these are the timestamps, source and destination IP address, source and destination transport port, protocol identifier, and then just 2 counters, packet delta count and octet delta count. And here I'm putting the numbers of the information elements, and this is the only thing that shows up on the wire. The only thing that shows up on the wire is you get 21 followed by 8, then 22 followed by 8, and then 8 followed by 4, and then 12 followed by 4, and so on, because the names and the other information about the information elements can be retrieved from the registry, so you don't need to put these on the wire. So because, and then if we have a data set that has set ID 261, that refers back to template ID 261, and that data set would have a selection of flow records. And then those flow records would essentially just have, so the values for those information elements for that record in the same order. So you'd have 8 octets, which would be the time in milliseconds of the start and the end of the flow, the source and destination addresses, the source and destination transport ports, the protocol identifier, delta count, and octet count. So one of the nice things about the templates is you can essentially define as many of these data record structures in a message stream as you like. Let's say, okay, we're exporting IPv4 information. We want the same information for an IPv6 flow. Okay, we'll just export a new template that refers to the IPv6 addresses as opposed to the IPv4 addresses, and then you see here those would be encoded as such. So you don't need to really, this is the other point of the flexibility is that you don't really need to export everything about the flow. If all you really want to do is count octets over a time window per source address, so if you're basically trying to do sort of traffic matrix, you're looking for heavy hitters, you could use the smaller template and then you're exporting much less information. So this could be something that came out of a mediator, or it could be something that came out of a dedicated exporting process whose job it was to do this sort of measurement. So I said we'd talk about options templates later, now is later. So these are actually one of the hardest things to explain about Ipfix. I don't really fully understand them myself, and I've been looking at them for the past 8 years. So it's a special type of template used to define records bound to a specified scope. Okay, what does that mean? So really one way to think of it is that a flow record describes an observation of a flow, while an options record, or a record that's described by an options template, describes a mapping. It basically says, when you see this thing that is the scope, this additional information is associated with that thing. So you could say, for example, you could associate a source network with a WLAN SSID, for example. So you wouldn't have to export the WLAN SSID in every single flow from that WLAN. You could basically say, anytime you see a source address that's in this /24, know that that is provisioned to this WLAN SSID, for example. Another example is the flow key indicator. So this is actually something that's specified within Ipfix itself. How do you know at the collecting process what the flow key is at the metering process? The metering process has to know what its flow key is because that's how it splits the packets into flows. But you'd like to be able to export that information to the collecting process. So for example, with Benoit's example, you'd know, am I also splitting these flows on output interface because I'm expecting to be doing some packet-based load balancing. So the flow key indicator is information element number 173. And if you look at the definition of that, it basically says that it is a bitmap of bits of indexes into a given template. And if the bit is set, then that index in the template is a flow key, and if it's not set, then it isn't. So if we look at another one of our templates, so if we go back to template ID 261, which we saw at the beginning, this flow key indicator says that those 5 information elements are the flow key. Now, the record is associated with the template via this scope information element. So this scope information element says that this flow key indicator applies to any record that has this template ID. So when the collecting process then sees records associated with that template ID, now it knows, oh, I have this flow key indicator for this template ID, and it applies that flow key indicator. So then that information is available for every record associated with that template. You don't only need to use, I think you can use essentially every information element that isn't a counter as scope. You could even use information elements, counter information elements as scopes if you wanted to say, here's some information I know about all 40-byte packets. I don't know why you'd want to do that, but it's completely allowed. You can associate things with IP addresses, with IP address ranges. You can associate things with observation domains, with observation points, with anything that you can model using an information element or a set of information elements in Ipfix you can use as a scope to do this sort of binding. One other thing is, so with respect to structure, Ipfix essentially does things in terms of streams of messages, right? So it's like the message is self-contained, and that's the unit of transporting this on the wire. But it's a stream of messages that's taken together, all of the messages within a given transport session, because remember you have these links between data sets and template sets in the stream. So earlier template sets later template sets can refer to earlier template sets. Scope, it can also be bound across messages and so on and so forth. So we realized that if you basically just took a whole bunch of messages that were related to each other and slammed them together, concatenated them together into a file, you had a storage, sort of a storage and caching mechanism for Ipfix. So we defined Ipfix files. These are in RFC 5655. One way you could see it is as a file system transport for Ipfix. You take a bunch of messages, you put them in a file, and then you can do anything that you want to do with files. You can encrypt them, you can compress them, you can stick them in an HTTP request, you could copy them with Sctp, so on and so forth. One of the really nice things about this is that since it's just a message stream, now Netcat becomes a TCP exporting and collecting process, right? You can just take a file, you cat it across the network, boom, you're exporting TCP. Or you're exporting Ipfix over TCP. So one other thing, we've been talking about the structure of Ipfix records, and everything is relatively flat. So all of these templates, one way to think of it is a template describes a table, right? So you have the names of your columns and the data types of those columns. But not everything that we want to do in measurement can really be flattened out like that or efficiently flattened out like that. So really the problem that we ran into here was how, you're doing a multicast flow, right? You're sending stuff out. You have a multicast flow, it comes into a router, it gets cast out. How do you represent all of the interfaces that went out? Right, you could have one flow record, each of which had one interface, but that's clumsy and you really can't, that's not really clean to interpret later on. If you know all of the hops in the path, you don't necessarily just want to say the next hop, you can represent the entire BGP AS path. How would you do things like stacks, like label stacks and MPLS, a list of time performance metrics? There are a few things here that you might want to bind in. So we defined RFC 6313, the export of structured data in Ipfix. And we'll go into this a little bit, but not in a whole lot of detail. Essentially, Ipfix structured data defines three types of things: a basic list, a subtemplate list, and a subtemplate multi-list. So these essentially allow you to, within a data record, add some structure underneath the data record. So a basic list is essentially a list of values of a single information element. Right? So you could say, instead of saying the export or the output the output interface for this flow is a single number, you say the output interface for this flow is a basic list of output interfaces, and then that basic list would contain all of those. The basic list contains also semantics for being able to state whether you're saying that all of these values apply, or any of these values apply, exactly one of these values apply, or none of these values apply. So you could say in a basic list, I know I didn't send it out this interface. I may have sent it out any other interface, but it didn't go out this one. So you could also say, not in the set here. So it's a very flexible way to represent sort of more semantically structured information than you can with sort of the flat tables. Now, the downside of that is that you also need to be much smarter at the collector to be able to interpret that once you get it. But if you need to do this, then this is the way to do it with an Ipfix. A subtemplate list is somewhat more complicated. So this represents a list of 0 or more interests. Let's go to the meat here. So this is directly out of the document. So basically this allows you to say all of the, inside this element in a data record, there are multiple instances of another data record that is described by a single template. So it's basically a way to put a data set inside of a single data record. So it gives you the ability to wrap a set in a record if you don't want to just say, this is a list of, okay, so here's the MPLS, this would be a pair of label stack entry position and value. So you would have a subtemplate that said label stack number, MPLS label stack value, and then it would go 1, and then the entry on the stack 2, then the entry on the stack 3, then the entry on the stack, and so on. Subtemplate multilist is even more complicated. I personally haven't come up with a reason to use it other than it's really kind of cool. Where subtemplate list allows you to put an entire data set in a record, subtemplate multilist allows you to put an entire Ipfix message body in a record. So it essentially says, you know, I mean, really at the parsing side, it is go into this data record and then start parsing another message. So if you have like almost an entire Ipfix message that is strongly bound semantically to a single record, you can export that in a subtemplate multilist. So one example here is performance metrics. Actually, Benoit, do you want to talk about this one, because this is sort of your
So if we go back to the subtemplate list, there is one thing which is interesting is the last example of performance metrics, right? We start to do performance metric monitoring along with flow records, but somehow people believe that we could be sending performance metric on a regular basis, like at the microsecond level. Well, not really. So what we could do is we could have a flow record composed of 5 different tuples, and then we could say, well, at this time, I saw this set of performance metrics, the one-way delay, the packet loss, the jitter. Then at time number 2, I saw a different set of performance metrics. And somehow, the use case we see for that is that in a typical branch office, we would like to monitor the performance, but we've got limited bandwidth to export the flow record. And if we export every single flow record, every single time a performance metric changes, well, we will saturate the link. So this is what I'm telling there, that we could do aggregation in time and also in space by using this structured data, right? So a branch office with one export limitation, we would send performance metrics on a regular basis, and this is somehow combining 2 works that we did in Ipfix. First of all, the mediation, which is grouping flow records, and then the structured data.
I mean, we have been working on this for quite some time, so it's probably not all that surprising that there is running code. But we'd like to show you sort of a little bit of a demonstration of just looking at the protocol structures is anyone here familiar with IPython and IPython notebooks? So we've put together, and I'm going to run through it here, an IPython notebook for sort of exploring these structures with a Python Ipfix implementation. Hold on, let me turn off. So if you're on a machine that has pip or easy, is that on? Yeah. Hello? Yeah. So if you're on a machine that has Python 3 on it, you can basically just go type pip install Ipfix and get a alpha quality piece of code for building Ipfix messages and parsing them. And what we're going to do here in this demonstration is we're going to build some messages with this Python API and then show you what they look like on the wire. So essentially, we have sort of this API. We write bits of Ipfix into a message buffer, and then there is a piece of really pre-release code in that module that renders that down to SVG drawings. So let me, I don't know that I got a chance to start this. So basically, if you, if anyone wants to look at this, I can send you the URL later. Come see me, and this is sort of a way to sort of start working with this Ipfix stuff. We have a little bit of code that has to be run in order to load the various bits of the modules. And then because the information elements sort of, you need to actually have sort of a basic registry of information elements. So we took the IEs from IANA and RFC 5103, which is biflows, and they're sort of hard-coded into the module. So if we run that piece of code, we now, all of the information elements that we have are available. So let's go back to that flow that we looked at earlier, sort of the simple five tuple flow. We have a template, with the various names, and the template looks like this. Like I said, it's got the number 261, followed by the count 9, and then basically just 152.8, 153.8, so on and so forth. And then we can use that to encode a record. So here we create a message buffer, we add the template to the message buffer, and then we export a record to the message buffer. And what this looks like is this here. So here's an Ipfix header. Like I said, we have the version, the length, a sequence number, an export time, an observation domain. Then followed by that, we have a set ID and a set length. Here's that template that we just looked at. We have a set ID, which is 261, which refers back to this template ID, and then just a bunch of data, which we can then interpret based on the fact that we know what that template is. Again, like I said, you don't have to have a template in every message. So if we just do a, so is that a question or a stretch? Ah.
Sorry.
Yeah, sorry. Yeah, anytime, just jump up and make noise. I know I'm going rather, okay, go ahead.
How are you doing the SVG rendering? Is it part of the API?
So inside the Ipfix module, there's a module called Ipfix Viz, which I hacked up in a couple of hours in order to give this demonstration. So it kind of works, but it's a use at your own risk sort of thing. But yeah, so the reason that that's in the, at some point, if people are interested in sort of using that for debugging Ipfix, I would be, I'd be open to, documenting that. But yeah, so it's basically just drawing out raw SVG and then rendering it in IPython. Okay. So here again, message header, here's the length, a set, and this set now contains 2 messages. You'll notice there's basically no boundary in the encoding between the messages. So essentially the way when you're decoding an Ipfix message, you have a set ID and a set length, and then you just keep decoding messages until you get to the end of the set. So everything is length prefixed as opposed to sort of marker boundaries on the structures. So we also talked about reduced length information elements and variable length information elements. Here, this is in a syntax that's defined in the IE Doctors draft, so it's a compact way to talk about information elements in text. And here it said we want to use octet delta count, and we want to make it 4 bytes as opposed to 8. And then we want to encode the WLAN SSID, which is a string and is therefore variable length. And what this looks like is there's 2 things to note here. So here we have octet delta count and packet delta count. Oop. The length is 4, whereas if you go back to the previous template, which is here, the lengths are 8. So now the collector knows that it's dealing with reduced length encoding. And then for any variable length information element, there's just in the stream, there's just a length prefix. So this is, if anyone's familiar with Pascal strings, this is basically just a Pascal string with the ability to have an additional encoding for things that are between 254 and 65,510 bytes long. So it's interesting to sort of like illustrate. Oh, actually no, that's the next bit of the demo. So we actually have to talk about, where are we? We have to talk about protocol dynamics first. So that was basically IP. Oh, go ahead. Yeah.
Yeah. I don't think you covered this. I came in a bit late, but I've just looked through the slides, and I don't think you covered it. If you're wanting to keep referring to the same 5 tuples, say, about a flow, is there any way to assign an ID to that so you don't have to keep repeating it?
There is an information element called common properties ID, right, which you can use as a scope field in an options template, where you hear for the options template part.
Yep.
And then basically you just say that common properties ID 1, and that has all of these values. There's an RFC specifying this called reducing redundancy in Ipfix export. It's one of the 5400. It's 5470X. But yeah, so there is a defined mechanism for doing that.
Okay, and could you alternatively just run it through a compression algorithm that does that automatically sort of thing without the intelligence of...
You could, but we haven't defined an interoperable way to do that.
Okay.
And so files, we do talk about compressing files. So if you really, really want to do compression in an interoperable way now, put it in an Ipfix file, gzip it, and send it to yourself by FTP. But that you don't get a lot of sort of the nice dynamics of using Ipfix in that way, right? Yeah. We considered at one point talking about compression, but we basically dropped it because in a lot of these cases, we're really trying, if you go back to the original use cases, we're trying to make it really, really easy to write really, really dumb exporting processes so that we can run them in sort of spare cycles on forwarding devices. And adding a compressor in there kind of, that's a slightly different design philosophy.
Okay, and I have another question about, you mentioned that you can specify a flow key by a combination of different things.
Yep.
Is there some sort of regular expression language to define that, or is it just all equals?
It's just all, sorry?
I mean,
yeah, it's just all, yeah, so
yeah.
Basically if it's in the flow key, you do equal comparisons on the things and then it stays in the flow key, and if it's not, then there's no, yeah.
You can't have any conditionals and all the rest of it?
No.
Okay.
We considered that for doing aggregation at one point in the working group a long time ago.
Yeah.
And we ran into two problems. One is, it really sort of reduced to the let's design a language that we're going to, let's design yet another language problem. And the other problem is, there's a bunch of different ways to do these aggregation things, and we don't want to sort of like standardize the least common denominator and end up breaking some of the things that you can do. So that would be an area for future work. Other questions about structure before I go into how this stuff all flies around the internet? Okay, cool. So like I said, Ipfix is really sort of, it's best to think of it as a stream of messages that go from the EP to the CP. And the messages generally map to messages, segments, or datagrams in the underlying transport. This is a little bit less, there's a much less strong binding between an Ipfix message and a TCP segment in TCP, because TCP doesn't guarantee segment boundaries anyway. But for SCTP, an Ipfix message is an SCTP message. For UDP, an Ipfix message is a UDP datagram. So next. So we have these three transport protocols. Who here knows what SCTP is? Who here doesn't know what SCTP is? Okay, SCTP is the Stream Control Transmission Protocol. Good, we'll have a couple of review slides coming up after this. It's the mandatory implement protocol for Ipfix. It provides partial reliability, multiple streams. The most important thing is it provides congestion awareness. There are some issues with implementation. It is not as widely implemented as TCP and UDP, although we are working very hard to change that. Huh?
It's been around on the idea that needs 5 years. Why hasn't it been implemented?
Are there any SCTP guys here? We can take that one offline. I have the same question. Yeah. Yeah, there's a ton of TCP. There's problems with middle boxes that they're trying to fix, so on and so forth. But it's got a lot of really, really nice features for Ipfix, so we defined Ipfix in terms of it anyway. Then with TCP, it's intended for sort of transport of Ipfix across the internet, especially where you want to use security over TLS and you don't have a SCTP implementation.
If I can come back to why SCTP not implemented is, if I speak for my customers, most of them, they export from routers into their own domain, right, not across the internet. So that's one reason. Now, in a previous implementation, we had a SCTP, but it was not really used. It's only now that I see some customer interest doing that specifically for billing, if you want to use Ipfix for billing.
And then there's my personal least favorite IPFix transport, UDP. So it's got no reliability, no congestion awareness, and there's like a big long list of warnings on don't do this. So it's really intended for deployment. It's really intended for deployment on devices where you've already built a flow collection infrastructure using protocols based on UDP, and you've already done all of the separating your traffic off onto a separate network, and you don't really care about loss too much, and you don't care about the corner cases that you can get into. Benoit may have a slightly different opinion of that.
I do, actually.
And we can talk about that at the reception after.
Because one of my customers have to export 13 million flow records in hardware. I mean,
yeah, that I will say is one really nice thing about UDP. If you're trying to put things together in hardware or in extremely limited environments, then and you don't want to have to pay for a TCP stack, either in terms of the overhead in terms of 30 million flow records, or even the overhead in terms of one on a very, very small device, then UDP has its place. So Sctp, for those who don't know what it is, stands for Stream Control Transmission Protocol. It's actually been around the internet, or the IETF, for 14 years. I think the first RFC was in 2000. Huh?
Everybody
yeah.
to move on that.
Yeah. It's got a bunch of features above TCP and UDP. So you have streams, so you can basically separate different sets of, different queues within the same association. You have partial reliability. You can essentially mark a message and say, if you're unable to deliver this message after a certain point in time, stop retransmitting it. This was something that was defined for telephony and other sort of media transports. And it turns out it's really useful for flow records as well, because if you sort of are running into a flood, or you're running into a problem where you can't actually you can't keep up with the export, then TCP does very badly here, because there's no way to cancel reliability. You can do unordered delivery, and then there's also transport layer multi-homing. So you can open an association from one endpoint to two other endpoints, or n other endpoints, and then you sort of get automatic sort of failover. It's also got a simpler state machine than TCP with a, you can sort of select the features that you want a la carte. Partial reliability is an extension to Sctp. So you can skip free transmissions for packets that you've labeled as not requiring reliability when you haven't been received yet or acknowledged yet. And this allows us to have multiple applications with different reliability requirements running on the same association. And you can also, basically the big win here is you can get best effort reliability while having TCP level congestion control and congestion awareness. The other thing here is that if you've sort of been thinking about these structures, a lot of this stuff breaks if you can't receive your templates. Right? So you get a template and the template's lost, and you get a whole bunch of data records and you have no idea what you just saw. So under Sctp, this allows us to have reliable transport for the templates, while we can select reliable or unreliable transport for the data records depending on how, and we can also assign priorities to those data records, saying these data records are more important because it's billing, and this is information that would be nice to have, so we'll send it unreliably. So that those won't get retransmitted and the billing stuff will. So then with streams, you can also logically separate sort of different planes within Sctp. Here we basically say we don't provide a whole lot of guidance with using streams in the Ipfix protocol itself. We say, export on whatever streams you want to. Be aware that you may have templates on one stream that have data records exported on another stream that refer to them, so you have to be careful about that. But then we did define in RFC 6526 a mechanism for getting a few extra features if you restrict how you use streams. So basically, if you say that each template has its own stream, or each group of templates has its own stream, then you can get per template reliability information, because the sequence numbers are bound to the streams. So that's sort of how we do transport. There is sort of a template management process that has to run here, right? It's like in the very, very simplest case, you open an association, you send some templates, and then you send a bunch of data records that are referred to by those templates. Now, Ipfix associations, Ipfix sessions can be very, very long running, right? They can be as long running as the collector is up and the router is up, and these things don't go down very often. So you may say, you go to the metering process and you enable a new feature on the metering process while it's running. Well, that's going to need to be able to send new templates. So that starts up, it tells the exporting process, send some templates, and then it sends some information off. You may disable features during runtime, and then you don't necessarily want those templates taking up space in the state of the collecting process, so you can then withdraw those templates. You may be in a situation where you have a whole bunch of different record structures, and are running into the fact that you can only have about 65,000 templates within a stream. There are a few, this is not I don't even want to say this is not a general case problem, but there are a few applications we know of where this is an issue. And there you can withdraw a template and reuse the ID. There are some restrictions on operation ordering, obviously, because you don't want to withdraw a template and then reuse the ID and then still be sending things according to the old template, because then everything will break. So that's how it works on TCP and SCTP, and here's why I don't like UDP, because template management is completely different. So Ipfix kind of makes this assumption that you have reliable transport for templates, and UDP doesn't give you that. We also scope templates to a session lifetime, so when we open a connection, we send some templates. Those templates are considered to be valid until that connection is closed. If a new connection between the same exporting process and the same collecting process is opened, you resend the templates, right? The collecting process doesn't keep state beyond the connection lifetime of the connection between the exporting process and the collecting process. It's really difficult to define a connection lifetime for UDP. So we have a completely different template management regime for UDP. The exporting process has a bunch of templates that are considered as active set. Periodically, it resends them all. The collecting process discards templates periodically, and we actually tried very hard to come up with a set of usable guidelines so that you could say, here's where you should set your timeouts, and it turns out these are different based on your application, based on your load, based on a whole bunch of different factors, that there is really no good guidance that applies in every case. So we just made these independently configured and mandate that you log if there's a problem so that the administrator can figure out that these values should be adjusted. So for security, and a lot of this flow measurement stuff, again, so in history, you'd have all of your devices sort of on the same network, right? You'd have your your metering process and your exporting processes, and then maybe at the top of the rack or in the same room, you'd have a collecting process that was then moving this along. You'd have a dedicated UDP network so that you didn't have problems with your measurement traffic interfering with your data traffic. But then, okay, now maybe we want to do federation, maybe we want to do things across domain boundaries. We'd like to be able to transport this across the open internet, and you don't necessarily want to be sending flow records about all of the traffic on your network, unencrypted, unprotected. So we define bindings to TLS and DTLS. So TLS is used to secure TCP transport. Everyone here has an idea of what TLS is? SSL, okay. Does everyone know what DTLS is? So D stands for datagram. It's basically TLS defined for transport over datagram semantics. The other thing you can do if you don't necessarily want to be running TLS is you can have some sort of external tunnel with IPsec and then run Ipfix over that. We require strong mutual authentication via X509 certificates. The EP then, because it's initiating the connection, acts as the DTLS client. The CP acts as the DTLS server. We do require mutual authentication because it's just important to make sure that you're connecting to the right collecting process as it is to make sure that you're receiving data from the right exporting process. So we can have another look at some actual flows running over Ipfix. Now here, we don't really have space to put a whole rack on the table over here, so I'm going to run everything inside my MacBook Air. And here we have a metering process, exporting process called QoF. This is a pre-release open source flow meter. If you want to see a little bit more of what it can do, come to the NMRG session on Tuesday. We have a packet trace. We run it through this. There's some configuration, a file which is done in YAML. So it's not, we don't use the netmod, the Yang module in QoF yet. It's one of the reasons it's pre-release. And then we run it to the collecting process running inside the running inside of IPython, and then we dump it out to SVG so we can see what's happening. So actually I need to drive the... So it's really kind of difficult to, how do you demonstrate a flow meter? Because it really is, packets come in one side and Ipfix comes out the other side. And it's, you can have a bunch of text scrolling up the screen, but that's sort of that is the definition of the least inspiring demo. I know that probably a lot of people in this room think it's awesome. I do too, but I wanted to do something a little bit different. So we're going to actually look at the configuration file. And one of the things about QoF and many other sort of flexible Ipfix metering processes is you define what what it is the metering process is doing based on the template that you're telling it to export. Or alternately, you tell it what sort of data you want to export, and a template is generated from that. So there's a natural relationship between the information elements that are going to go out of the exporting process and the functions that are being done at the metering process, which is kind of obvious if you think about it, right? I mean, you're measuring data, you want to be able to export it. You don't measure things, you're not going to export, so on and so forth. So you'll notice here that, so this is just basically a YAML file. We've basically commented out the IP address information because we can't show you IP addresses because the people who gave us the traffic would be very cross with us. And it's Germany, and I'd probably go to jail. But you can see here there's a big list of information elements here. Many of these are IANA information elements. Some of these are enterprise-specific information elements. Let's actually tell it that we want to take a look at, actually, where are we in the notebook? Yeah, so let's tell it that we want to see just a flow ID, or a serial number, start and end times, transport ports, protocol identifier, and then we want to look at packet and octet delta counts, and initiator and responder octets and packets. So these are sort of above the IP layer counters. And then let's actually say that we want to, why not? We'll look at the round trip time on the forward and reverse side in milliseconds, and then we are going to run this and hope that it doesn't. Oh, no, we're not going to run it. So basically here, this in Python is an Ipfix collecting process. We basically have I don't know if anyone knows Python socket server. It's a very easy way to build TCP socket-based servers. We basically just tell it, hey, I want to open a server, and then I want to open that stream of messages. This is this R file, and I want to open one of these message stream renderers, which is an object that spits SVG out. And then I just want to look at the first 20 messages that come out of that, and I want to stick them in a buffer so that we can look at them. So I'm going to start that, and then I'm going to start that, and then I'm going to cross my fingers. Okay, I haven't seen an error message yet. Oh, SIGPipe. Why did I get SIGPipe? Oh, I know why I got SIGPipe, because the collecting process sort of unceremoniously dropped the connection when it had received enough data. So now we can look at the messages. So what happens on startup is actually you can see that the messages that we often get are somewhat larger than the messages that we were seeing in the demonstration. So this is a 486 byte message that has a single gigantic template in it, this is the exporting process saying these are all of the information elements that I know how to export. Then we have an options template. So one of the options templates is the process reliability options template, which essentially says I'm going to send you, every so often I'm going to send you how long the system has been up, the total count of messages and packets that I've seen, total number of packets that I've dropped, total number of messages that I've ignored, so on and so forth. So that's sort of the message that gets sent at startup, and then we look at another message. And here's that reliability template. We've seen 32 packets so far. We haven't exported anything. We haven't dropped anything. We haven't ignored anything. And then these are these are enterprise-specific information elements that we don't know anything about. So I haven't told I haven't told this collecting process what these are, so it just says, hey, I got this thing that's private enterprise number 6871. I got 100, and here's the value in bytes, and figure out what to do with that. This is because this is sort of one of the points of enterprise-specific information elements is unless the collecting process has some information about what those are, then it doesn't really know what those are. It just knows that this thing is of that particular size. Then we send some more templates. Actually, there's one thing that I wanted to say about enterprise-specific information elements. In the template, if the high bit of the information element ID is 1, then that's the way that Ipfix signifies this is an enterprise-specific information element. So this says that this ID is 32769, which is greater than 16K, so it's okay. This is a enterprise-specific information element, and this is the private enterprise number for that element. So there's another RFC called RFC 5103, which is for exporting byflow information, and it basically says that there's this special private enterprise number, and if you see that private enterprise number attached to an information element, then that is the reverse version of a counter for the forward version if you want to export byflow information in a single flow. And then we have actually here a couple of other enterprise-specific information elements, pin 35566, that's me. And here's, yes, another template. It's very long, and then we export another template ID. And then we export yet another template, and this is the template that we actually asked for. So this is the abbreviated template. And then from there, we start exporting flow records. So here's flow ID 59. It started here, it ended here. It's a single packet flow, and it's got 40 octets in it. Like I said, most flows are really tiny. Here's another packet. These are these single packet flows that are going through. And then as you sort of continue, here the metering process, or the exporting process decided I need to send a new template, so another template goes in. This also shows you that, we say in general, you send a bunch of templates, then you send a bunch of data records, but because of this template management, the data records and the template records are often interleaved with each other. And then we have more data records, and so on and so forth. So here you can also see that within the stream we have a set, which, this is set 45203, because this template is, because this is a byflow, so it's got forward and reverse information in it. And then we go back to 45202, which is a single direction flow, and then back to 45203. So you can also interleave multiple sets in order to keep records in order when you're switching among templates. So you don't necessarily just have to say, here's all the records from this template, then here's all the records from this template. You can interleave these things fairly freely within the stream. And so on and so forth. So if you go and you download this particular IPython notebook, and you have an Ipfix exporting process, you can simply just point it to here and it will print out all of the various things. So that was a lot of information. Did everybody kind of follow that? Mm-hmm. Did anyone completely not follow that? Questions?
Hi, Babu Bajpai, Jacobs University, Bremen. We have been internally using YAF as the flow exporter.
Yeah.
I see that you are using QoF.
Yeah, QoF is basically just a fork of YAF.
So it's a new version. Should we use the QoF now?
No. Actually, talk to Chris about that.
Okay.
Not about QoF.
Not about QoF, yeah. Talk to me about QoF, talk to Chris about YAF. And actually come to NMRG and I'll explain the differences between them.
Perfect, thank you.
Yeah. Okay. I think we're on time then.
All right, so we saw a lot of technical details. Now I want to take a step back and see the cross-area application. And it's not only about Netflow version 10, right? So I want to see what we could do with that. And I want, taking a step back, I want you to make sure you understand that, okay, Ipfix was done initially for flows information, flow record. We've seen L2, L3, L4 headers, right? And we've got some flow-specific terminology in there. But somehow it's applicable to something which is way more, which is bigger than just flows, right? Every single time that you want to export, you need directionally a large amount of data of the same structure. Ipfix could be applicable, right? And then we've got this template mechanism in which you can define even your own information elements if you don't think that your information element should be in IANA, all right? And by application here, we mean use cases. And we'll see a couple of examples where Ipfix was used. And one of my message here is to mention that if you're not been dealing with Ipfix, right, and you work in a different working group at IETF, and you want to push some data, maybe Ipfix is applicable to you. And the only thing that you need is a couple of extra information elements. And keep in mind that you can even define your own, right? So somehow this is the message I was giving you, that Ipfix became a generic push mechanism. Yeah. And I want to show two examples. And one, I mean, I learned about that one maybe a couple of months ago. It's about a phase shift keying, which is something in amateur radio. And they use to report this whenever they receive a radio, just have to type HTTP there. Whenever you receive a radio signal, I mean, they use Ipfix to tell the world, this is what I'm receiving, right, as a radio frequency. And somehow, I mean, they use Ipfix, they use their own enterprise information elements. We had no clue about this, but it just works. Right? That's what I call reusing Ipfix for something which is not flow related. Okay? I thought it was cool just to show that. Another one is in my own company, and something I was not aware of, right? I'm supposed to be a Netflow architect, but I was not aware of that. And they had this firewall, and you know, there are plenty of logs in there. And you know, it could be 100K connection per second, so a lot of logs. And someone had the idea, okay, can I replace this log by Netflow or Ipfix, right? Whatever, it's the same thing almost. So what they did is that they compare and they saw a number of gain in terms of connection that the firewall could sustain, because Ipfix takes less resource than just syslog, right? So it was a real advantage. On top of that, you know, syslog is plain English text, while Ipfix is composed of information elements. So let's say you've got IP addresses, right, in syslog. Well, which one is first? You do NAT, right? Inside, outside, source, destination, right? With Ipfix, you have the exact semantic at the exact position in the template. Okay, next one. Now, in terms of different application, different use case, there was a working group in the past here, PSAM. It stands for packet sampling, right? So it does sampling and filtering of packets. So, you know, we've got, what I mentioned in Ipfix, we've got packets that arrive, they create flow records with multiple packets and bytes. Here, we're dealing only with packet information. And what they did, I mean, yes, what we did in PSAM is that we agreed to use Ipfix as the export mechanism, right? We're sending always the same structure to a collector, so Ipfix is applicable. And we have defined a couple of information elements that are PSAM specific. And that was it. Same information model, same protocol, just new information elements. Right, next one. Okay, and for reference, these are the specific RFC in PSAM, right? And what I want to show here is that one of the first slides, I mentioned the difference between metering process and exporting process. The exporting process, we have standardized Ipfix. For the metering process, in case of having a single packet in the flow, this is psamp, right? So if you go to the next slide, metering process, psamp, exporting process, Ipfix. And we spoke a little bit about packet information into the requirement there. And we share the same information, but the key message here is that in psamp, it's simply a flow record composed of a single packet, right? And what I showed there is that we had a YANG module to configure Ipfix. And it's also applicable to configure psamp. Same thing. So, I mean, those two are simply complementary. There is no more boundary. And actually, just for a little story, in the Ipfix IANA, we said we're going to start by having all the psamp-related IE at a certain value there, right, having a gap. And now, I mean, that gap is filled in. And we are at 400. And you can pick up for psamp-related, for Ipfix-related IEs, or whatever, right? psamp history, I mean, for reference there, this working group is concluded, by the way, 3 years ago. Yeah. Now, talking about your use case, right, and that's a thing I've seen a couple of times in BOFs in the IETF, that I've got the question like, is Ipfix applicable? Yes, no. Now, this is my message here. I want to make sure that based on this session, you would be able to see if Ipfix could be applicable to your work, to your own use case. But what we have defined here, knowing that most of the time it's simply requesting new IEs, we've got this IE doctor thing that Brian mentioned. It's right now in the RFC queue, and it's a set of guidelines for two types of audience. First of all, for the Ipfix reviewer, we're going to approve the information elements, but also for the people who would like to request the information elements. Right? The goal is to have consistency and usability. Basically, we say, if you want to define your new information elements, just try to make sure that you are consistent with what we've been doing, that you don't duplicate information elements. And I think that's about it. Yeah. So now we want to show you a typical example of using Ipfix for something that is not flow related. Brian, in a couple of hours, did a great job of just making up an exporter. So feel free. I like it.
So actually, I'll you know, because there was a little hardware hacking involved here, I want to wave the hardware around. So I suppose many people are familiar with this. This is a Raspberry Pi. On the other end of the Raspberry Pi, through a very, very robust set of wiring that I just now sort of hacked up, is an AM2302 temperature and humidity sensor, which has this horrible sort of semi-Manchester-based one-wire encoding that fortunately somebody wrote a driver for, so I didn't actually have to hack it myself. It's really kind of cool. Go look at it on the web. The data sheets are all in Chinese. And I wanted to show a few things here with this particular thing. One is, I talk to people about Ipfix a lot, and they say, well, that can't possibly be applicable to my use case because that's something for core routers, right? And I'm trying to do this on a set-top box, or I'm trying to do this on a mobile phone, or I'm trying to do this on this little thing that's over here. And basically, the only reason that I'm not holding up an Arduino right now is because that would have taken a little bit more time. So I wanted to show that it's possible to get an exporting process running on a relatively small machine. Actually, I will also say that this machine I've also done some testing on. I can run QoF or YAF. I've tried it with both. It'll actually export flows monitoring a 100 megabit Ethernet connection on this one machine. So you can do fairly interesting stuff with Ipfix in fairly constrained environments. The second thing I wanted to show here is that you don't really have to have a full Ipfix stack in order to export Ipfix. One of the design goals of the protocol was that it should be capable, if you have a fixed length data structure, you should be able to define a static template and then have a few static message structures that you can just poke some information into and blit it out on the wire. Right? So I have the code is up on GitHub somewhere. But it really is. There's, it's 1 or 2K binary that just has a couple of fixed C arrays, and then it pokes some information into that C array and puts it out. Actually, it doesn't put it out on the wire, it puts it out on standard output. Because that's the third thing that I wanted to show, is that if you have a stream of Ipfix messages on a Unix box that has INC on it, you can export Ipfix. So I'm hoping that this thing booted. Haha. Nobody watched me type the default password. So let me make this bigger. So this is basically the command line. There's this temperature relative humidity. You can't really see that pointer. There's this DHT temp RH. That basically is the thing that reads the temperature off of the sensor. It pipes that into a little Unix utility that reads those numbers as floating point text and turns it into an Ipfix message, and then spits Ipfix messages out through standard output. And then it runs that through netcat. So this is an Ipfix exporting process in 3 processes. And then let's go over to the tutorial, and we are going to close that, and it is going to warn me. So this is another notebook that you can download and work through, but we're kind of low on time. So I'll just go ahead and run the code, because that does have sort of, that has code that has to run so that the collecting process can run. The thing here is that, if I want to build an Ipfix-based temperature sensor, I need to have an information element so that I can export the temperature, because this doesn't exist in IANA yet. What would be really cool would be to just sort of like say, hey, we're going to define this ambient temperature Celsius thing, and we're going to run it through the IE doctors process. A couple of the IE doctors are actually in the room right now. There might be someone from IANA, and we could just get it done really quickly. But again, as I said, we're running low on time, so we're going to do it the cheap and experimental way and define a enterprise-specific IE. But what you'd want to do is you'd want to go ahead and write that up and maybe put it on your website if it's something that you want to publicly use. People can figure out who you are based on your SMI private enterprise number, and then they can go to your website and they can try and find your registry. So, if you operate one of these, you should sort of operate a registry. The registry should probably say things like, here's the name of the information element, the description, ambient temperature measured in the environment associated with an observation point or a meeting process. It has an abstract data type, it has some units, and then it has a range, because we don't necessarily need to, we put the range at negative 273.15 because we don't need to talk about temperatures below absolute 0. And then you get, again, a message would look something like this. But let's go ahead, since we have a temperature and humidity sensor, let's also define a information element for humidity. And then let's start, essentially, this is a copy paste of the same really cheap collecting process that we ran in the last demo. And then we start the exporting process, and it says, yes, I'm exporting these things. And actually, I'm going to go ahead and hold on to the temperature sensor so it gets a little bit more warm in here.
That could be useful for the email thread and temperature in the room.
Yeah, exactly. It's, as I was thinking about what do I really, I wasn't intending for there to be a 37-degree heat wave in Berlin this week. When I put this together, it's like, what do people, how can we apply this maybe not to a use case that, a lot of people have, but is maybe sort of IETF relevant? And I'm like, oh, right, we have the temperature in the room situation, so let's look at the room temperature. And here's the first message. Like I said, it has this static template. It just blits the static template out. There's the export time, observation domain, and then you have, the ID, and it's got an observation time milliseconds, a observation point ID. So this we added to the template. So if you had a device that had multiple temperature sensors on it, you could then associate each one with an observation point. You can see very easily how you could turn this little toy demo into something that you could use for system management with sort of very little changes whatsoever. And then we have our ambient temperature Celsius, which is then has this private enterprise number, and then our relative humidity %. And then we look at the first message, and we see that it's 25.7 degrees in the room, and the relative humidity is 55.5. And then we look at the next message, and 5 seconds later, it's not that much warmer in my hand, but it is significantly moister. And then we do that again. And yeah, now the relative humidity is 25.9 degrees and 89.4% humidity. And now even I'm complaining about the air conditioning, and so on and so forth. So that is, hopefully that's sort of given you a picture of this isn't just flow, and this isn't just for big machines. So any questions about this demo? If anyone wants the code for any reason, drop me a line.
Well done. I like it. So I want you to close this now with some more potential applications or use cases in the IETF. And one of them is in LMAP. If you know about LMAP, we're going to have our first working group meeting this week. It stands for Large-Scale Measurement of Broadband Performance. And obviously, we want to push performance metrics one way or the other. And I'm a big believer into trying to get an information model first. And well, obviously in Ipfix, like we've seen now, there is a need to have all the rooms sending their temperature to complain to the concierge. So we might have temperature in Ipfix. I'm just kidding, right? But performance metrics. So there is like a need to get potentially, there is a potential need to export performance metric from broadband devices with Ipfix. We're going to think about the solution, right? We don't want to go into the solution now in LMAP, but feel free to attend. It's tomorrow. No, it's Tuesday morning. All right. Then it might be relevant also to IPPM, because IPPM, they're busy right now trying to define a registry for performance metric, right? And we know that we will need to export performance metrics with Ipfix. And we know that vendors are doing that already with enterprise-specific information element. That would be great to have a single registry that could be used for IPPM, for LMAP, and also exported with Ipfix. Right? So that's one of the things we're trying to solve this week. If you know about this, SIP-CLF is a common logging format, right? At some point in time, we were evaluating whether or not we could be using Ipfix there. And I want to have this session recorded, because if in the future we have buffs in which Ipfix would be applicable, I would like to be sending the link in advance. Please review this session. At least you would understand if it fits your use case or not. Right? Yes. And then last section, what if you want to learn more about this, right? So the first thing I want to show is what are we doing in Ipfix, in the Ipfix working group right now. I believe this is one of the difficulties in the IETF. Whenever you want to learn about a working group, you jump on a train, but the train left the station already. So it's difficult to see, okay, what are you working on? What are you building on? Right, so let me try to explain this. And we will have the Ipfix meeting tomorrow at 10. So please join if you're interested. But, okay, we have 5 different documents in the RF queue, so those are done. 5101 and 5102, I told you these are the 2 primary RFCs for Ipfix. We have the BIS documents of those, right? Minor changes there. But 5101 BIS is the protocol. It became like the full standard. Okay. The iDoctor, we spoke about that. This one is the flow aggregation. How to aggregate flows on the mediation. This one is again on the mediation. How to select flows, right? What if I want to only select the flows whose prefix is blah, and then send it to a specific collector? This is defined there. Yes. Now, the things that we're going to discuss in the Ipfix working group is the following. First of all, whenever we speak about the mediation, we will have an Ipfix protocol for that. And it's almost consistent with the Ipfix that we know already, but there are a couple of extra rules, right? If you do aggregation between flow records, you have to mention which flow start and flow end you want to have, for example, right? If you aggregate from different devices, maybe the observation domain, remember the line card ID, has changed, right? Because it's not consistent. Thing like that. This one contains a series of information elements for layer 2. This one, we still have some work to do there. It's about exporting MIP variable using Ipfix. The idea is the following. Okay, we've got 400 information elements in Ipfix, and we've got tons of MIP modules, right? So do we want to define every single MIP variable that is interesting into Ipfix? Well, not really. We did it already for some, right? Whenever we've got the ingress interface or egress interface, these are the IF index, right? Obviously, we want to keep the same, but let's say that I want to have the number of drop in my QoS class. Well, do I need to define that? Maybe I could just point to the OID in the MIP and say, well, this is what I'm going to use in Ipfix, but if you know the semantic, go and have a look in the MIP, because it's fully defined, right? No duplication of data model, please. Okay, and then we have to think about what to do next if we want to do something. I mean, Ipfix, we started like 12 years ago, right? We had the final check today with sending the temperature on a Raspberry Pi. I mean, that's a success. So maybe it's time to declare victory. Or what we could do is, well, there are a couple of things there. There is a discussion on, do we want to have a slightly modified Ipfix information model? You know, we spoke about performance metrics, so maybe it would be good not to have jitter min, jitter max, jitter percentile 99, etc. So maybe there is a small improvement we could do there. There will be also a presentation on the endpoint trying to send information that they know about regarding the application. Well, I know this is like a meet echo application because the endpoint tells me, right? So if I've got a specific QoS policy in my router and that meet echo should have like real-time class map, right? Then I could do that. So that's the current work. If you're interested, join. Now, the last 2 slides, I believe, is, okay, you learn a lot about Ipfix. Now, what if you want to learn more by reading documents? Where to start? 2 cases. The first one is you just want to learn about Ipfix. Start with the architecture, then the protocol, 5101 bis, then the information model, 5102 bis, and if you care about the mediation, read that one. You will get a good summary. It's always something difficult in the IETF, right? You want to review SIP. How many SIP RFC do we have? I mean, I don't want even to know this, but I will try to say, okay, maybe for tomorrow, right? So my goal here is just to say, start with these. Now, the next slide. If you just want to know, someone told you, well, maybe Ipfix is applicable to you, then in that case, read a different set of documents. Start with the applicability. Okay, it's quite old. It might worth having an update, but it still gives you what the applications are for Ipfix. Then start with the IE doctors, because you learned today that if Ipfix applies to you, then you might just need a few information elements, like the temperature, right? So read the type of guidelines we have for defining information elements. Let's say that you're thinking, I want to push energy information via Ipfix, because it's the same thing on a regular basis. Maybe it's applicable, right? So I don't know. So read applicability, extrapolate if it works for energy, then see if the IE doctors would be compliant there, and that's it. And then go into the details of the protocol and information model. And then ask us if you're not sure yet. All right? And this is the the last slide. So at this point in time, we welcome any questions you might have. Or it was just clear.
We should have had a quiz.
Yes.
Yeah, well, we need the price.
Ah, that's why we didn't.
So then, thank you. I hope you enjoyed that. It was useful to you.
Thank you very much.
Thanks.